Hello everybody, in this video we're going to be looking at distance time graphs. So distance time graphs are all very similar to each other. The axes are always the same. We always have time going along the bottom here and distance going up there like that, okay? So it's quite interesting as we move this diagonal line here. Well, that is kind of moving away from an original starting point, isn't it? As time moves across, okay, we're going up, we're covering distance. So it's quite interesting that the steepness of the line, therefore, represents the speed. So the steeper the line, the faster it is we're moving, the faster that we're getting to that distance away from the starting point. So if the steepness is the speed, when it's flat like this, it means when there is no speed, we're not moving at all. Time is ticking along, but there's no change in distance. If we get a sort of negative gradient or negative steepness like this, it means we are moving, we are traveling at a speed, but we're going in the opposite direction. We're returning back to the starting point that we came from. So I mentioned speed earlier on. So if we have a distance time graph like that, we could actually calculate the speed from this. If we look at the change in distance between any 2 points, so from here and here, the change in distance is like the rise, okay, and we divide that by the time taken, because speed of course is distance divided by time, we're going to get the speed that we're looking for. So we could potentially calculate speed from a graph by doing the rise divided by the step. Okay, let's have a look at some example questions. So here is a distance time graph, and it shows how far a child is from home. So let's have a look at what we're going to do here. Well, we're going to describe how the child moves. So I shall say this in words rather than writing this down. So the first part of the journey is this motion here, like this movement here. So what's happening there is, first of all, the child is moving away from home. We're moving away from home at a constant speed because we've got a constant steepness. And we're moving away 1,000 meters, and that's taken 80 seconds. Now, the second part of this journey is this part here, this horizontal section here. Now, at this point, the child is not moving. The child remains in the same position for 20 seconds and doesn't move. And then the third part of this journey is the return back to the starting point, so the return to home. So at this point, from a time here to here, we've got a movement back towards the starting point. Now, if we're going to do part B, let's work out the speed of the child on each part of the journey. So in the first section, we'll call it section 1 here, we have got to work out the distance divided by the time. Well, we can see that the distance travelled was 1,000. So we've got 1,000 and divided by the time taken. Well, the time taken is 80 seconds. So we're going to do 1,000 divided by 80, which is 12.5 meters per second. So that is going to be the speed travelled in the first part of the journey. Now, the second part of the journey was this part here. Well, I've already mentioned this, there was no speed because we're not moving. The distance sort of travelled is 0 at that point. So that is a speed of 0 meters per second. The third part of the journey we can work out. Now, let's think about this. Just because we're going in the opposite direction, it doesn't mean we should have negative speed. It doesn't really make any sense. We've got to do the same thing as before. Well, if we start here and we return back to home, we can see we've covered 1,000 meters again. But if we started at the point at 100 seconds and we finished at a point at 200 seconds, that means it's taken us 100 seconds to get back to home. So we've got to do 1,000 divided by 100, which is, of course, 10. So we've got 10 meters per second as the speed on that part of the journey. Okay, now let's have a look at how we would construct one of these graphs ourselves. So in example 2, we've got Rebecca who drives at 50 miles per hour for 2 hours rests for 1 hour, and then drives another 70 miles in 1.5 hours. So we've got to potentially draw this on a distance time graph. So first of all, just have a look at this and make sure we understand that when we draw our axes, we need to be very consistent. It's always distance going up, and we're going to go up by the same amount each time. So in this example, we've chosen to go up in 20s every 2 squares, and we've gone up in sort of half-hour chunks going across, and that's got to be consistent starting from 0. So let's have a look what this might look like. Let's take away the bit we can't see, and here we go. So first of all, we have to make, how do we get this line? Well, we've got 50 miles an hour for 2 hours. So obviously, we're going to have this point stopping somewhere on this 2-hour mark, right? But if it's 50 miles per hour for 2 hours, well, how much are you going to cover in that time? You're going to, of course, have covered 100 miles, okay? 50 in the first hour, 50 in the second hour. So you can see that it kind of had to be at that point there. And because it is sort of consistent here, it's just going to be a straight line connecting those 2 points. Okay, the second stage is a rest stage, and as we already said, horizontal line means rest. We're not going to be moving from that 100 miles distance away from our start point. We're doing that for an hour. So if we were at 2, we're now going to be at 3, and you can see it's got to be flat line there. No problem at all for that. Right, and then we're going to drive for another 70 miles in 1.5 hours. So we need to go across 1.5 hours and then up 70 miles to 170, and there is where we're going to end up. So we kind of draw our line like that. So that's how the graph was constructed. Right, bit of further analysis now and some more challenging sort of questions. Here is a more difficult graph. It shows how Tom's distance from home varies with time when he visits Ian. So let's go and try and answer these questions. So how long does Tom spend at Ian's? Well, let's have a look. We've got, it's going to be the horizontal part where he's there. So obviously we're talking about this section between those 2 points. Now, how long is that? Well, if you think about it, this is at 90 and this bit here is at 40. So if we do 90 take away 40, we're going to get 50. So he spends 50 minutes at Ian's house. Okay, next part of the question. How far is it from Tom's home to Ian's? Well, if he starts at his own home and moves up here, well, we can see, nice easy question, it's going to be 3,000 meters. C. For how long does Tom stop on the way to Ian's? Well, on his way there, we can see there's this stopping point between here and here. Well, from 20 to 30 is 10 minutes. Now, at which part of the journey does Tom travel the fastest? Well, the fastest part is going to be the steepest part. So we've got to look at the 3 parts where he's moving. So we've got 1 there, 2 there, 3 there. And I think that this number 2 here is the steepest part. So that is the part of the journey that we're really looking at here, this second part. So let's get rid of these things here. So, okay. Should we calculate that perhaps? Let's calculate that now. Okay, so if we are at 1,000 and we want to get to 3,000, we can see the distance travelled there, let's write this at the top, is going to be 2,000 kilometres. Okay, and how long did it take him to get there? Well, from 30 to 40 is 10 minutes. So we've got a time of 10 minutes. Now, if I wanted to calculate that speed, well, I could do 2,000 divided by 10, and that would get me 200 meters per minute. Okay, I realise I made a slight mistake. It shouldn't be 2,000 kilometres, it should be 2,000 metres at the beginning. So 200 metres per minute anyway. Now that's not a very good thing, so perhaps we should try and convert that to something more useful. Perhaps, I don't know, kilometres per hour. So let's convert it to kilometres per hour. So first of all, if we start with 200 metres per minute, let's get that into metres per hour. So I'll times by 60, because there's 60 minutes in an hour, and that will get me 12,000 meters per hour. And then now I'm in hours, I want to convert to kilometers. What I'll do is I'll divide by 1,000, and then we're going to be in kilometers per hour. So if I do that, we'll be in terms of that 12 kilometers per hour. So there we go. That is the fastest pace that Tom walked on that second phase of the journey there. Right, part E, how fast does Tom walk on the way back from Ian's? Well, let's do this the quick way. We'll just worry about this in terms of meters per minute. So we have walked a distance of 3,000. And we have taken from 90 to 120, so that's 30 minutes to get there. So 3,000 divided by 30 is 100. So he walked at a speed of 100 meters per minute. And perhaps we could convert that to kilometers per hour, but we'll leave that there for now. Okay, that should be enough to access the questions. Good luck, everybody.